So in this video, we are going to repeat the same thing that we did for the MLOps part on Azure, but now you're doing it on the cloud, on the Google Cloud platform. And the story is the same. So you have a certain machine learning problem, data set can be found on Kaggle, and you have built a certain solution. The web app looks like this. It's very simple. You put in your years of experience, and then you get a prediction how big your salary should be. Obviously, you already trained your model. It's here, it's in a pickle file. You used this Python file to train it and drop it here, and then model.py to expose it. You use Flask for the web part, and you already have your endpoints and everything is tucked in. Now the question that you pose is, how do I build in some MLOps principles so that I make sure that the technical debt for my MLOps solution is reduced and you really get the biggest value while deploying your machine learning solution. Very quickly going through this tutorial and just want to showcase the comparison when talking about the Azure part. What's the equivalent services that can be found on the Google Cloud platform? And if we go through the architecture here, and obviously we are now having a different ML model and different ML solution, but the architecture from the previous video is somewhat similar, right? So we have our website where we basically make these predictions, and then we have certain Google Cloud services that need to be integrated with our GitHub, where we store our code, and then basically based on a trigger, we're going to trigger a continuous deployment pipeline that's going to pack everything together, do the testing, deploy the artifacts on certain services of Google Cloud that are basically just managed services that allow us to execute our app and deploy the Flask application. And additionally, what's not to be found in the previous video is the integration with the storage bucket, where we just store our data to do basically another retraining iteration, where we can, in this case, execute just this main.py and then get the desired pickle file. And again, as in the previous video, here you can go into details in the code and the other comments. I just want to outline the basic similarities between the both. You see that when you clone the GitHub repo, which you can do directly either on the cloud, Google Cloud platform, or by your locally, you execute the make call, which is basically installing the requirements and doing all the linting and testings. Then you can train the model, and then you can expose it with the main.py. If you do that on a cloud, Google Cloud project, then there are a couple of commands that allow you to do this, where you just have to make sure that you're pointing to the correct work project or working directory. You set up your GitHub repo with the Flask application. And then basically with these two lines, with Google Cloud builds and run deploy, you have simulated somewhat similarly what happens with the Beanstalk on the AWS, or previously what we discussed on Azure. These two are very important to have low upkeep solution that allows you to deploy basically your machine learning code. But what we are here for, and what's the main point of the whole MLOps discussion, is integrating with the continuous integration, continuous deployment part. Is we need to set up a new triggers from the GitHub part with our Google Cloud platform. Basically, we want to make sure that when we are on the main branch, when we have merged a feature branch to the main branch, that we are triggering a continuous deployment pipeline that basically then tests and deploys the artifacts that can then run on this app engine, and then that can be then used to serve over the salary predictor website. And this can be very easily achieved. As I said, we just need to connect it, as in the previous video, with our GitHub platform, the Google Cloud GitHub account. We have to connect it to our Google Cloud platform. We have to set up triggers, basically when it's going to happen, when we, as I specified, when we merge feature branch to the main branch, and all of the CI steps that we need to do are specified in the cloud build YAML. If you remember, Previously, the equivalent to this was the Azure DevOps.yaml, where we specify different stages and steps that need to be executed depending on the depending on what was previously successful. And then when when the build was successful, then we push the artifact and we can basically have a new code on our managed solution from the Google Cloud platform, the App Engine. And that was basically it. What we need to set up the continuous deployment pipeline. That was obviously a very high overview and not a detailed explanation how to set up this. But finally, what you can also do is load test your current deployed solution. So really see how many requests does it manage to handle, and how does it perform in the areas of high traffic. In this case, obviously, it's very good to have these numbers and then compare them. If for a certain endpoint call, for example, for post, which is a predict endpoint, a lot of requests, as we see in this case, over 2,000, it doesn't have failures and it can handle them all successfully.